Hi folks, welcome to video number 181. This one's on trigonometry and the cosine rule. So the keywords are trigonometry, cosine and inverse. Trigonometry is the branch of mathematics that allows you to work out missing side lengths and angles in triangles. Cosine is one of the trig ratios that we use in this topic, and inverse means when you go backwards or undo something. So the method states, use this rule when you have a tidy looking question. Okay, what I mean by that is if you've got all three side lengths, you're going to be able to calculate an angle using the cosine rule for angles. And if you've got two sides and an included angle, you can find a side length using the cosine rule for sides. These are rules you have to memorize. You have to have these up here in your head. It's not that difficult after you've practiced them to remember the rules. It just sticks. It just does. Okay. To find a missing angle or side in a non-right angle triangle, you go through this process. You label the angles, big A, big B, big C. You label the sides, little a, little b, little c, which are opposite the big letters. Write out the formula, which you've remembered. Substitute into the formula, calculate. Inverse if you're finding an angle. So the difficult thing, the most difficult thing I think I've found, or students find, is what rule to use and when. And yeah, it's just knowing that you can use it for tidy questions that seems to help. I find that's how my mind sees it anyway. All right. So find the value of x. Give your answer to one decimal place. So I'm going to do that over here. I'm going to do the working out for it. There's barely any room, right? And it's quite difficult to see. So here's my working out. We've got a triangle that I'm going to label the angle big A. Right, the angle that we got is useful in the cosine rule to label the angle that you get or want as the big A. Then this is going to be little a. Then this can be B, big B, little b, and then big C, little c. All right. So let's substitute into the formula, the cosine rule that we've got up here. Like I said, got to remember it. So a squared plus, I've got to remember it, and there's me starting it off incorrectly. A squared equals B squared plus C squared minus 2bc cos of A. Okay, that is it. That sticks in your head after a little while. So a squared equals b squared, which is 28 squared, plus 22 squared, minus 2 times by 28 times by 22, multiplied by cos of the angle, which is 18. There you go. That's what we type into the calculator to get a squared. So a squared is, and let's bring the calculator in and find out. So 28 squared plus 22 squared minus 2 times 28 times 22 times by cos of 18. Got it. 96.29. 6.29 something something something. Therefore, all we've got to do is square root, because undoing the square is square rooting. So square root that answer, and we get what A is. A is 9.81 something. Okay, so x is our value here of A. So x equals, and it's in meters, so 9 to one decimal place, 8 meters. All right, hopefully all of that makes sense. Substitute into the rule. It's nice because it's in the video. It's in the video for the specific skill. Like I said, the hardest thing is deciding that it is the cosine rule that you're allowed to use. Okay, so like I said, let's label in this question here the angle that we want to find this time, big A, then little a is opposite there. Okay, this one can be B, little b, doesn't matter which one's which, and then that can be little b. Right, so this time we're using the rearranged version of the cosine rule. To rearrange it, you add the 2bc cos A to the other side, you take away the A squared, all right, and that goes onto the other side there, and then you just divide by the 2bc that's in front of the cos A. Leaves you with cos A equals, all right, which isn't the actual final answer because then you have to inverse after that. But cos A equals b squared plus c squared minus a squared. Again, a rule you could just memorize over 2bc. Okay, let's substitute the numbers in and get what cos A equals. So cos A will equal, cos of our angle is going to equal whatever we get when we substitute in to this part of our formula. So b squared, 8 squared, plus Oh, did I label that one B and that one B as well? I did, didn't I? Silly me. All right, that one's C. So that's going to be B squared, which is 9 squared. Doesn't really matter which way round we do it. 9 squared plus 8 squared minus A squared. A squared is 14. That one matters. Okay, matters which one that one is. And that's over 2 multiplied by 8 multiplied by 9, or 2 multiplied by 9 multiplied by 8. Okay, so let's get that calculation done there. Cos A equals, let's just write it down here, cos A equals, and then whatever that gives us. So 9 squared plus 8 squared minus 14 squared. That's 11. 14 squared. All over 2 times 9 times 8, which equals minus 17/48. I'm going to write it down as a fraction, minus 17 over 48. Because that's not our answer. Alright, we want to inverse that to get rid of the cos. So A equals, the angle equals, cos to the minus 1 of our answer. Okay, so all we got to do is press shift and cos and then answer and then equals. And that's 110.74. So x, in this question, equals 110.7 degrees. Okay, that's our answer to 1 decimal place. Hope it all makes sense. It's the most basic versions of these questions that we could do, but like I said, these are not easy questions. They're grade 7 in their own right, aren't they? So question number 2 asks us to find the perimeter of the triangle, and the perimeter is just the distance around the outside. We've got 2 of the lengths, so we must need to find this final length, right? This is a nice exam style question for the use of the cosine rule, right? So let's label that A and therefore that little a. Okay, and then this one can be little b, and that's our big B, and that's our big C, and that's our little c. All right, so we're just going to substitute in, and we're going to find that length, and then we're going to add all the lengths together to give us our answer for the perimeter of the triangle. All right, there we go. So it's the same process now as the very first question, 1a. Substitute into the rule. So a squared equals b squared plus c squared minus 2bc cos of A. It's worth writing it down every single time until you have got it implanted into your memory bank. A squared therefore is equal to 9 squared plus 7 squared minus 2 times by 9 times by 7 times by cos of the angle, which is 40. Alright, so a squared therefore is going to equal whatever we get on the calculator. Move it over a little bit and type it in. 9 squared plus 7 squared, I won't sing, minus 2 times by 9 times by 7 times by cos of 40. And there we go, 33.47. And some more numbers is what a squared is. So a equals the square root of that. Square root answer equals 5.78. And then our perimeter, so let's call it big P, equals that answer plus 9 plus 7. So just got to add on 9 and 7, and we get the perimeter of 21.786. 21.786 dot dot dot. So the perimeter is equal to, let's round it to 1 decimal place, what it did with the last one, 21.8 centimeters. Just using the cosine rule there, right? Obviously, because it's in the cosine rule video, but there you go, to find the perimeter. Question number 3. 2 ships leave port P at 10 AM. Ship A travels on a bearing, so we've got bearings in here, at a speed of 25 kilometers an hour, so we've got speed calculations to consider as well here, because we don't deal with speed in these triangles, we deal with distance, alright, so we need to find the distance using the speed. Now, ship B travels on a bearing of 256 degrees at a speed of 36 kilometers an hour. Calculate the distance between the ships at 1 PM. Okay. So this is a very, very tricky question, I think, where you've got to really interpret what it is that you need to do. You've got bearings, you've got speed and distance and time, but it ultimately is a cosine rule question. obviously because it's in this video. But I'll show you why it is. Okay, so we've got the time here between 10 AM and 1 PM. That's 3 hours. All right, just make a note of that. Okay, that is how long these ships have travelled for at the speed that they're travelling. Okay, so the distance calculation is going to be the speed multiplied by the time. Okay, if you're not sure about that, go back and watch compound measures, speed, distance, time video. The distance is the speed multiplied by the time. So 25 kilometers times by 3 is 75 kilometers for ship A. Okay, that's ship A can go that. All right, and ship B, 36 multiplied by 3. The distance that ship B goes is going to be 108 kilometers, because 36, is it 30? Yes, it is. Yes, 108 kilometers. So now we know the distances those ships have gone. This makes it a little bit easier. And we've got the port P. So let's just say there's port P, right, with our north line going up like that, because bearings always do that. There's point P. And 190 degrees, well, it's just gone past the 180. So if we're going directly down, so there's 180. So there's our 190 degrees, all right? So there's our 190, and that's 75 kilometers, let's say. 75 kms. Okay, 256, well, there's 270 there, so we'll just estimate it to be like around there-ish. And we've got 108 kilometers, so I've drawn a longer line. Okay, and there's our ship B, that's where it is, and there's our ship A. All right, there's B. And we just need to calculate the distance between the two ships at 1 PM. Well, that's where they are at 1 PM. We figured out that because of the speed, distance, time calculation. And we know the angles that these are, all right? We know that's because you always measure bearings in a clockwise direction from a north line. So that's our 190 degrees there. That's our 256 degrees there. So we could calculate this angle in the middle here. We could do the calculation where we take away 190 from 256. We find a difference between those angles, which is 66 degrees. All right, so we've got 66 degrees here. Now this has turned into a cosine rule question because we've got one side length, another side length, and we've got the included angle. All right, and we want to find this. Right, so and this is where we might need to relabel. Okay, we'll call this A, okay, and this can be C, because that's already B, so that's avoiding any confusion there. That's already B, so we'll call that little b, and then we'll call this A, we'll call that C for our rule, and then that's little c, and therefore we're finding little a over here, and that's going to be our answer. So we just do what we did in that previous question now, right? But getting to that stage is really, really tricky, in my opinion. So we've got a squared equals b squared plus c squared minus 2bc cos of a. Sub in a squared equals b squared is 75 squared plus c squared, which is 108 squared, minus 2 times by 75 times by 108. This really starts to hurt my hand after a while using this. Multiplied by cos of 66. Right, now if you do find that your rule, you're missing some numbers, you've obviously made a mistake, all right? So you have to go back and figure out, maybe relabeling it might help out. So a squared equals, let's get our calculator and do this calculation. So 75 squared plus 108 squared minus a 2 times by 75 times by 108. Did it again, didn't it? And then multiplied by the cos of 66 degrees. So that is 10699 point something. 10699.86 ... So a equals the square root of that. Square at that answer. We get 103.44, which is reasonable, isn't it? 103.44 kilometers, and that's rounded to 2 decimal places there. And I'm going to write that as my answer. So the distance between them is 103.44 kms. Okay. Now B, we've got to calculate the bearing of A from B at 1 p.m. So I'm going to get rid of all of that working there, just so I've got a bit of space. It doesn't look confusing. It takes a little while to get rid of. There we go. Right, now the bearing is the measure of a turn from a particular point. So from B, there's B, so we've got to go from B, draw a line that goes up from B, right? And we want to get from here to here, there to there, all right? Now, we can work out what this bit is because we know what this bit is, all right? This bit here, okay, let's do this calculation first. That bit there is 360 degrees, the whole turn around. Take away what the angle was to get to there, which was 256, which is in the question. So 360 minus 256. 104. Right, so 104 degrees there. Now we know that this one and this one, as our C angle fact, that one and that one have to add up to 180. So this angle here, 180 minus that answer is 76 degrees. So to that point there to there, 76 degrees, right? Now we need the rest of this angle in here, all right, which again is using the cosine rule, but we're using the cosine rule for angles, all right? We've got all three side lengths, okay? So we can use all three side lengths to find the angle because we got the side length in the first part of the question, all right? And I'm going to use that because that was fairly accurate, 103.44. That's going to give us a good enough bearing. There. Normally you wouldn't want to round through a problem, but that's what I'm going to use, 103.44 kilometers. All right, so let's just write out the cosine rule to work out what this angle here is. Let's call it angle X. All right, and yeah, let's go for it. So that's going to be, might have to relabel this again, all right, but let's just change it up. Let's do cos B. Be careful, all right? So cos of B is equal, and we're swapping the A and the B around, all right? And that we'll call our A still, and that's our C, the one that I've circled there. Okay, so cos of B is equal to A squared plus C squared minus B squared, just changing the letters in the rule there, hopefully this isn't confusing you, over 2AC. Just swap the A and the B, like I said a number of times. So I'm going to substitute now the numbers in for the letters. So my A is 103. I'm just going to type it in because I haven't got enough room to write things down neatly. So 103.44. Or was that my last answer? I can't remember if it was my last. It must have been. But I'm going to just use that. In fact, I'm not. I'm going to do that. And I'm going to go 103.44 squared plus the C squared, which is 105, no, 108, sorry, 108 squared, and then minus the 75 squared. And then all of that is over 2 multiplied by the A, which is 103.44, multiplied by the C, which is 108. Okay. Typed it all in, got that decimal, that's all good because that's what cos B equals. So cos B is equal to 0.74 something. And then B is equal to, and that's the angle. We're not quite there yet either. So that's going to be shift cos, no, that's not what I wanted. Shift cos answer equals 41.48 degrees. Okay, and then that's what we have to add on to that 76. So just for the final answer of the bearing of A from B, add the 76 on. And we get 117.48. I'm going to round it to one decimal place. So it's 117.5. Wow, pretty pretty tough stuff. Yeah, so hopefully you've learnt from that. That's some of the hardest stuff that you're going to get to do with the cosine rule. And my hand is genuinely really aching after all of that. So I'm going to give it a break now. I'm not going to do this for a little while. Yeah, thank you so much for watching. Take care of yourselves. Look after one another. Have a lovely rest of the day. Yeah, keep practicing. Bye-bye.